Alright, so the Pythagorean theorem is basically a squared plus b squared equals c squared. That's the formula. It can be used to find the hypotenuse of a right-angled triangle, or it can be reversed to find one of the legs if you're given a hypotenuse and another leg. We're going to be doing both of these, so make sure to stick around if you want to learn how to do both versions of this. So basically we're going to start just with an example where we are given a right-angled triangle with the measures of one of the legs being 6, another being 8, and then we are going to be trying to find the hypotenuse, which in this case is c. So basically we're going to start by squaring every single one of these values to follow a squared plus b squared equals c squared. So we're going to take 6 squared, that's 36, 8 squared, which is 64, and then we're going to be getting c squared, which we don't know yet. So 36 plus 64, that's 100. So c squared is equal to 100. Now we're going to take c squared, which is 100, and we're going to square root that. We're going to take the square root, and the square root of 100 is 10, meaning that c is equal to 10. Alright, so let's just do one more to make sure that I got my point across. So remember the formula, a squared plus b squared equals c squared. The next one, we're going to be given a right-angled triangle again, this time with the measures of the legs being 9 and 12, and we're still trying to find c. So basically we're going to take 9 squared plus 12 squared, and we're going to get c squared. So 12 squared, that's 144. 9 squared, that's 81. And that's going to be giving us c. So c squared. So c squared is going to be equal to 225. And now we're just going to simply take 225, take the square root, and that is going to be 15, which is our c. So let's just try something a little bit different. We're going to be trying to reverse it. So this time, we're going to still have a right-angled triangle, but this time we have the hypotenuse, which is 25. Alright, and we're also given another one of the legs, which is 7. It doesn't really matter where you put this, so don't be too worried about that, but usually, now this is not in all cases, but mostly the biggest leg is going to be right here, but not always, so just be prepared for that. But this is just a general assumption that you might be able to make when you're drawing it. So we're going to take 25 squared this time, which is going to be 625, and that means that we have b squared, and we don't know b squared, so we are trying to find b squared. But our a is going to be 7, so we're going to take 7 squared, that is 49. So 49 plus b squared is equal to 625. So instead of adding these, now we're going to be taking 625 and subtracting 49. Now this is going to be giving us 576. And now all we have to do is take the square root of 576, and that is going to be 24. That means that b is equal to 24. Alright? Okay, let's try another one. So this is going to be that same thing. We're trying to find b because we're given a and c. So same formula, a squared plus b squared is equal to c squared. You really want to drill that into your brain so that way you know it. So we're given another right-angled triangle, because this only works on a right-angled triangle. You can't do a scalene or something like that. It just doesn't work. So we're given one leg as 15 units. and our hypotenuse is going to be 17 units. So that means we're trying to find B. So we're going to take 15 squared plus B squared is equal to 17 squared. Okay. So now we're going to square all these, so that's going to be 225 plus B squared. You always want to leave that value in there so you don't forget about it. And then 289. So now we're going to subtract 225 from 289. And that's going to be giving us 64. So B squared is equal to 64. So now we need to find what B is. So we're just going to take the square root of 64, and that is going to be 8. So that means that B is equal to 8. Alright. So hopefully that helped you. And yeah, make sure to subscribe. Thank you. Bye-bye.